So the reference angles are always acute angles. But what about non-acute angles? How do we evaluate the trigonometric functions at non-acute angles? In this video, I will introduce a very convenient way. That is, whenever we know the reference angle of a given angle, we can make use of the reference angles to evaluate trig functions at non-acute angles. So let me show you a case. So here, as we know, we can easily determine the location of an angle. For example, this one is in the first quadrant. And then if the terminal side is here more than 90 degrees, but less than 180 degrees, this angle will be in the second quadrant, right? So we can just classify some non-negative angles that is less than a complete rotation. So let's quickly write some angles. If the angle is bigger, is positive but less than 90-degree angles, so it is an acute angle. If it's bigger than 90 degrees but less than 180 degrees, it is in the second quadrant. So if it's more than 180 degrees but less than 270 degrees, it is in the third quadrant. And if it's more than 270 degrees but less than 360 degrees, it's in the fourth quadrant. So suppose the angle is not a quadrantal angle. So quadrantal angle is relatively easy to determine. So if you have an angle that its terminal side is coincide with the y-axis or x-axis, then, right, for example, this 0 or negative 90 degrees. So those are quadrantal angles. So those angles are easy to evaluate. Yeah, for us to evaluate trig functions at quadrantal angles. So we will not talk about that case, but we are looking at the angles that are non-quadrantal angles. So for all 4 different cases, right? For all 4 different cases, that means they are the angles in this range that is positive, but less than 360 degrees. So we are going to look at an example. Yeah. So in this example, we're going to look at this angle, which is now acute. Let's say we want to evaluate cosine 225 degrees. So if this is 180, so we need to continue. So, but it's this angle 225 degrees is less than 270. So, but bigger than 180. So it's in the third quadrant. Yeah, so we approximately here. So let me indicate, because it's a positive angle. So what I'm drawing right now, it is the angle in the standard position, but it has to be positive. So go counterclockwise. This is our 225-degree angle. It's more than 180 degrees, right? But less than 270 degrees. So in the third quadrant, let's decide the reference angle of the 225. The reference angle, if we denote it by theta prime, it is the difference between 225 degrees and 180 degrees. Yeah, if we subtract 180 from 225, then we can get the reference angle, which is formed by the x-axis and the terminal side of the given angle. So this is the acute angle theta prime, which is formed by the terminal side of the given angle and the x-axis. So we find it is 45 degrees. So now next, can we write cosine 45 degrees as the value of cosine 225 degrees? And be careful, because 45 degrees angle is an acute angle. The trig functions are always positive for an acute angle. So therefore, trig functions are always positive for any reference angle. So this is positive, but cosine 225 degrees is not necessarily positive, as we know cosine function is negative for an angle in the third quadrant. So we can put an equal sign as long as we put a negative in front of the cosine 45. So as a quick review for this angle in the third quadrant, if you pick the point, which is a point on the terminal side of the angle, then you can see you form a right triangle from the point, then the x is negative, right? Because the cosine value is determined by this quotient, x over r. So in the third quadrant, x is negative. Therefore, the cosine is negative. So to summarize, for an angle in the range between 0 and 360 degrees, we can quickly determine the location of the angle because we're familiar with those angles, right, that are less than a complete rotation and also positive. Yeah. So we can quickly determine their location. And then based on the location, we can decide the reference angle. And then use the evaluation of the function at the reference angle. But that's not necessarily the value of the given problem. So we have to address the sign based on the location of the given angle. Now what if we have an angle that is negative? For example, this is, for example, another angle, theta. So suppose we have an angle that is negative. So if you, yeah, it is more negative than negative 90 degrees, right? So it is possible for you to see that it's in the third quadrant. But you can find a least positive angle that is coterminal with this angle. How? All we need is to add to this angle a complete rotation. So if I add a complete rotation to negative 120 degrees, then I get a positive angle that is coterminal with this given angle. So that will be 240 degrees. So let's indicate 240 degrees. Yeah, so we get a 240 degrees, which is the least positive angle that is coterminal with this given angle. So if we want to find cosine 240 degrees, at least we can know immediately it is in the third quadrant, because we know that it's more than 180 but less than 270. So it's in the third quadrant. So it has the same value as cosine negative 120 degrees because they are coterminal. Now we go from there. Cosine 240 has a reference angle. So what is the reference angle? Reference angle will be denoted by theta prime. It is the acute angle formed by the terminal side and the x-axis, right? So that theta prime. So theta prime can be determined, which is 240 degrees minus 180 degrees. So we get 60 degrees. So you want to use cosine of the reference angle, cosine 60 degrees. But cosine 240 degrees and cosine 60 degrees can be different. But the difference, they differ by at most a sign. So we know cosine in the third quadrant is negative, so we must put a negative sign. And then one last step, what is the cosine 60? Cosine 60 is half. So with the negative sign, so negative half is the value of the original problem. So in this second problem, we have a negative angle that is outside of the range of 0 degree and 360 degree. However, for an angle that is negative or or more positive, more or larger than 360 degrees, you can always find a least positive angle, right? That is in this range. Then you can, for example, after we find the least positive angle that is coterminal with the given angle, then we can conveniently find the reference angle of the least positive angle. And then use the reference angle. By the way, we address the sign of the given problem, then we will find the final answer.